What is my gut doing to me? In this video, let's take a deeper look at the mechanics of the gut. Please like and subscribe. There are approximately 150 to 200 common and approximately 1,000 less frequent bacterial species in the gut. The genes encoded by the human gut microbiota, collectively referred to as the microbiome, are over 100-fold more abundant than the genes of the human genome. The colon harbors the greatest numbers of microorganisms in the human gut, with the vast majority of these indigenous microbes being strict anaerobes. The total weight of microbes in the adult human intestine is approximately the same weight as the human brain. Mammals and especially humans are highly social beings. Indeed, evolution may have favored the development of social networks, and thereby increased capacity of our brain, to enhance the transfer of beneficial symbiotic microbes. Understanding the development of neuronal circuitries underlying the social brain across the lifespan is one of the major efforts in neuroscience today. That microbes may play a role in the development of sociability has been proposed in the context of evolutionary-based theories of the benefits of mutualism in social survival. During the course of evolution, multicellular life emerged from unicellular life forms. The latter remain the dominant life form on the planet and often exist in a symbiotic or parasitic relationship with multicellular life. The nature of such relationships can have a major influence on the life cycle of plants and animals. Here, we propose that the development of a complex gut microbiota in mammals has played an important role in enabling brain development, especially in terms of cognitive function and fundamental behavior patterns, such as facilitating social interaction and effectively dealing with environmental stressors. Thus, future studies of how gut microbes contribute to the function of their host on all levels will play an important role in advancing understanding of disorders of cognitive functioning as well as disorders of social interaction such as autism and a variety of stress-related conditions. Within a relatively short period of time, results of clinical trials of probiotics, psychobiotics, and prebiotics in the treatment of common psychiatric disorders will be available. The general scaffolding of the brain-gut microbiota axis includes the central nervous system (CNS), the neuroendocrine and neuroimmune systems, the sympathetic and parasympathetic arms of the autonomic nervous system (ANS), the enteric nervous system and most importantly the intestinal microbiota. These components interact to form a complex reflex network with afferent fibers that project to integrative CNS structures and efferent projections to the smooth muscle. Through this bidirectional communication network, signals from the brain can influence the motor, sensory and secretory modalities of the gut and conversely, visceral messages from the gut can influence brain function. Less extensively studied, but increasingly appreciated, is the potential impact of the enteric microbiota on brain function. The gut microbiota consists of predominantly bacteria, but also contains archaea, protozoa, fungi and viruses, all of which have co-evolved with the human host. These microorganisms perform vital functions, which are essential for host health, including food processing, digestion of complex indigestible polysaccharides, synthesis of vitamins, and inhibition of pathogens. Article source: Collective Unconscious, How Gut Microbes Shape Human Behavior. This field of research is beginning to unlock the deeper mysteries of how our gut health impacts the relationship we have with the outer world. Take care of your health and the rest will follow. Rest when tired, work and patience solve most challenges. Listen to your gut health wisdom.